Good morning and welcome to the new lesson of pie chart. I want to recommend you to go through the previous video if you have not checked. So today's lesson is pie chart. So actually what is a pie chart? Basically pie chart is a circular form of chart where the whole dataset will be represented by a different parts. So without wasting our time, we'll come to the first program. See, initially I wrote here import matplotlib.pyplot as PL. Then I took a data set C is equal to, it's a list, Python list 17, 18, 8, 27, 69. These are the data members or the list elements, you can say. Now to draw pie chart, we can use the function pie. This is the function. That function belongs to the pyplot library. That's why we need to write like this, pl.py. Then within first bracket we need to pass this dataset as an argument C. Now in the next line I wrote pl.access equals. Basically this line will resize the pie or resize the circle, you can say. Now the next line pl.show, it will display the whole pie chart. Now if I run that program for you, you can able to see this is your pie chart. Now if I just exclude this line from the program, see what will happen. See, the size of the circle is little bit smaller than the previous one. If I on it, you can able to see that size is increased and the position is also shifted some right side. So what is actually happening here, that you can able to understand in the next program. See, now changing the radius of a pie. Suppose if we want to change the radius of that circle, for that we need to pass an extra attribute in the pie function. The name of the attribute is radius, as you can see, is equal to 1. Now if I run this program, so this will draw a circle with radius 1 unit. Now suppose if I want to increase it, I want to make it 2, and then if I run it, you can able to see the size of the circle is increased. So like this we can able to change the radius. Suppose if you want to display the frame, so for that purpose you need to pass another extra attribute called frame, and this will accept a boolean type value, either true or false. So if you write frame equals to true, so frame will be displayed. If you write frame equals to false, or if you don't write this at all, then frame will not be displayed. Like the previous one, the frame is not displaying. Now if you don't write, as I told you in the first program, if you don't write pl.access equals, then see what will happen. Firstly, I want to run this program. You can see this pie is fitted within that frame. Now if I exclude this line and then if I run the program, you can see what is happening here. The size of the circle or size of the pie is a little bit bigger now, and it's not fitting within the frame. Actually, the frame size will be equal to the radius of the circle in this case. That's why if you mention it pl.access equal, and then if you run it, then Python will automatically squeeze the size of the circle and fit it within the frame. So this is the purpose of pl.access function. And if you don't write the frame, if you don't activate the frame, this you cannot able to understand. Like in our first program, see, if you activate equals, then it will be like this, and if you just deactivate it, and then if you run that program, then the size is little bit smaller. You cannot able to understand the difference between this. Changing levels. Now suppose I want to give a name to all the different parts of a pie chart. For that purpose, what I need to do is I need to create another extra list where each corresponding elements will be the levels of each different parts. Suppose for 17, I'm putting the name as A. For this data 18, I'm putting the name as B. Similarly, next one C, D and E accordingly. Now, if I write pl.py C, comma, levels equals to L. Levels is an extra attribute that we need to pass if we want to put a level, and equals to, I need to give the name of that list. In this case it is L, that's why level equals to L. Now if you write here pl.show, the pie chart will be displayed with all the corresponding levels. As you can see, this 17 is the blue section, its name is A. Then 18 is this yellow section, its name is B. Then 8, it's the smallest, that's why the size of this C part is very less in compared to the other one. And you can see the last one is 69, its size is bigger than all the others parts. Changing the level distance. Like see in the next example, all the levels are appearing just beside all the parts. Now see in this example, here the distance between each individual parts and level that I have increased. So if you want to increase this distance, you need to pass another attribute in the py function that is called level distance. As you can see, the program is exactly same as it was in the previous one. Just only difference is I have passed here another attribute called level distance, and I give here the value is 1.5, and then if I run it, you will get this one. That means this distance is now 1.5. Now suppose if I want to change this distance, see what will happen. If I make it as 1, see all the levels are appearing at the boundary points of the circle, because the default radius of a circle is 1 unit. That's why this is happening. If you make it to 2.5, it will be increased. If you make it just 0.5, then it will be within the circle. So like this, you can able to change the distance of the levels from the radius or from the boundary of the circle. Next one is automatic percentage. Now suppose if you need to display the percentage for each of the parts, so for that there is a extra attribute available in pyplot library. By using that attribute, compiler can able to calculate the percentage automatically. The name of that attribute is autopcity or auto percentage, you can say. So how to write this attribute? See, you can always write like this: autopcity is equal to, I have passed a value. Now what is this value? See, this is the format of the percentage. Now if you write this in this format, m.n, that means total number of digits will be minimum m. Total number of digits, that is the minimum digit, will be n in the percentage, and n is the total number of digits that are present after the decimal points. And if you want it in points, then you need to write f for float, and if you want it in integer, then if you don't mention it at all. And to display the percentage sign, you need to give a percentage, and this argument will start and end with a percentage sign. So now you can see in this case what is happening. Firstly percentage, then 0.2. That means there will be minimum 0 digits, maximum n number of digits can be there. There is no limit to the maximum number of digits. Now 0.2, that means after decimal point there will be 2 digits, and f means this is the floating point number will display and there will be a percentage sign. So the answer will be like this. You can see in every case there will be exactly 2 digits after decimal point, and maximum there are more than 0 digits are available. Now see the change. If I make it 3, then what will happen? See, let me run this. You can see after decimal point there will be total 3 digits, exactly 3 digits are present, and total number of digits is more than 0. Now we'll come to the next example. Next one is also the same type of example. Here I have mentioned 0 to f. That means the result will be displayed in floating point number, and at least there will be 2 digits. Now the next example is how to change the color codes of each different parts. Now to change the color code, you need to pass another extra attribute within the py function. It's called colors. Check the spelling, colors. Then within third bracket you need to mention the color name or the initials or the hexadecimal color codes, and then if you run it, all the colors will be changed automatically. Next one is we'll talk about another attribute called start angle. Now see, what is a start angle? Start angle means the angle between the horizontal axis and the starting part or the first part of the pie. Now in this case, see, to change the start angle, you need to pass another attribute called start angle within the pie function, and since I have mentioned here is equal to 90, that means starting angle should be 90 degrees. Now if you consider the horizontal axis through the radius of the circle, and the first part is A, so the angle in between A and the horizontal axis, that means this one, this angle is 90 degree. So this is the purpose of start angle. Now suppose if I want to change it, if I make it to 45 degree, see what will happen. Say this angle is changed. Now with the horizontal axis, suppose if you consider a horizontal line through the radius of the circle, then the angle between the radius and the starting part is 45 degree in this case. So we'll come to the next example. Next example is how to putting a shadow in the pie chart. To give a shadow, you need to pass another extra attribute within the pie function. It's called shadow, and it will take a boolean type value, either true or false. If you write shadow equals to true, then you can see that shadow is activated, and if you write shadow equals to false, or if you don't write this argument at all, then shadow will not appear. Now the next part, this is very much important feature of a pie plot, that is explode argument. As you can see the picture, the parts of the pie will be exploded. It will be shifted a little bit from the center of the circle. So For this purpose, we can use the attribute called explode. And how much you want to shift, for that you need to define a list. Suppose E is the list in this case, and here I have mentioned some values. For the first part, it will consider the first value, that is 0.2. That means first part will be shifted 0.2 units, this A part. Then the next part will be shifted 0.6. This is very much bigger, you can see. The third part will be shifted 0 units. That's why it is intact with the center, you can see. Then the fourth part is 0.3. The red part, see, it is shifted 0.3 units. And the last part is also 0. That's why the last part is intact with the center of the circle. Now if you want to increase it, suppose if you want to make it 1, and if you run it, see, it will be shifted from the center of the circle. So this is the purpose of explode attribute. To give a border, you need to use another extra attribute called with props. See that attribute, and within this attribute we need to pass a dictionary. Now in this dictionary, the keys are line width and edge color, and their corresponding values are 5 and k. So basically what is this 5? 5 is the line width, and this edge color is k. K means black. If you want to change it, if you give it any other color, you can give. Suppose if I gave Y, then it will become yellow. Let me run this for you. See, it will become yellow. So whatever color or whatever width you can give. And to activate this grid, you need to pass another function, that is pl.grid. Within first bracket you can write true. So this grids will be activated. I believe all of you can able to understand this topic. So that's all about pie chart.